Students, good morning to all of you. Please observe this one. 1 by 2 factorial plus, it is mathematical induction. 1 by 2 factorial plus 2 by 3 factorial plus 3 by 4 factorial plus and so on to n. What about first term? First term is 1 by 2 factorial. First term is 1 by 2 factorial. So here given 1 by 2 factorial plus 2 by 3 factorial plus 3 by 4 factorial plus and so on. So here it is a first term, it is a T1, it is a T2, it is a T3. First term is 1 by 2 factorial. Second term 2 by 3 factorial. Third term 3 by 4 factorial and so on. What about nth term? Clearly nth term is n by n plus 1 factorial. Clearly Tn, that is n by n plus 1 factorial according to given sequence. Okay? So here if n is equal to 1, consider 1 by 2 factorial. If n equal to 2, consider second term 2 by 3 factorial. 3 consider 3 by 4 factorial and so on. So it is n by n plus 1 factorial is equal to, it is also consider n plus 1 minus 1 divided by n plus 1 factorial. Numerator plus 1 minus 1. So clearly it is n plus 1 divided by n plus 1 factorial minus 1 divided by n plus 1 factorial. Now this denominator n plus 1 factorial can be considered n plus 1 into n factorial minus 1 divided by n plus 1 factorial. So n plus 1 by n plus 1 remove. It is the nth term. Tn is equal to 1 divided by n factorial minus 1 divided by n plus 1 factorial. It is nth term. So now, but here we have to find the sum of n terms. Now, continuation. It is first term plus second term plus third term plus and so on up to nth term. Clearly, nth term is 1 by n factorial minus 1 divided by n plus 1 factorial. But here we needed sum of n terms. So according to this series, according to this nth term, what about first term? 1 by 1 factorial. It is 1 by 1 factorial minus 1 divided by 2 factorial. It is only first term. Second term, 1 by 2 factorial minus 1 divided by 3 factorial plus third term is clearly 1 by 3 factorial minus 1 by 4 factorial plus and so on. Last term is, that means nth term 1 by n factorial minus 1 by n plus 1 factorial. It is nth term. So here it is a positive term. One is a positive, negative. Next positive term, negative term. It is a negative term. Next term we get a positive. Okay? One is a negative, positive, negative, positive, negative, positive. All are removed. We get 1 by 1 factorial minus 1 divided by n plus 1 factorial. Okay? Already know that 1 factorial value 1. 1 by 1 factorial means it is clearly 1. 1 minus 1 divided by n plus 1 factorial. Please note down. Please note down as early as possible. Okay, ma? Please next. Second question. Please observe this one, ma. Second one. If sigma n power 3 into sigma n is equal to sigma n square whole square. Sigma n square whole square. Then what about n value? We know that sigma n into n plus 1 by 2. Sigma n square n into n plus 1 2n plus 1 by 6. Sigma n give that is n square n plus 1 whole square by 4. So here given sigma n power 3 sigma n is equal to sigma n square whole square. Sigma n give formula n square n plus 1 whole square by 4 into sigma n into n plus 1 divided by 2. Sigma n square whole square. First we have to write sigma n square n into n plus 1 2n plus 1 divided by 6. Divided by 6. That is only sigma n square. But whole square, na? So clearly it is n square n plus 1 whole square 2n plus 1 whole square divided by 6 square. That is 36. So n square n plus 1 whole square remove on both sides, ma? N square n plus 1 whole square. 4 nines. So remaining n into n plus 1 by 2 n into n plus 1 by 2 is equal to 2n plus 1 whole square divided by 9. Okay, na? Then verify if n is equal to 1 satisfy or not, 2 satisfy or not, or minus 1. Here given 3 options. It is only n square. So first n is equal to 1. If n is equal to 1, consider LHS value 1. RHS value also 3 square by 9. Na? 1 equal to 1 satisfy. Okay, na? Next n is equal to minus 1 substitute. If n equal to minus 1 means 0 is equal to 0. It is not satisfied actually condition. It is n equal to minus 1 consider. LHS is 0. RHS value 1 by 9. Both are not satisfied. N is equal to 3 consider. If n is equal to 3 consider, it is a 3 into 4 by 2. It is a 6. Okay, na? It is a 7 square by 9. 49 by 9. Both are not satisfied. So by verification, n is equal to 1. By verification, n is equal to 1. Please note down. Okay, ma? Next. Third question. Please observe this one, ma. Third one. Sum of 25 terms. Sum of 25 terms of the series 1 into 3, 2 into 5, 3 into 7, and so on. Here, first term is 1 into 3, second term 2 into 5, third term 3 into 7. Okay, na? What about fourth term? 4 into 9, and so on, up to 25 terms. Then sum. Here 3 plus then sum of all these terms. So here first we have to verify who is this, please. Fayaz. Fayaz. Hello. Fayaz, please respond, man. What's your problem? Fayaz.
Hello, sir. Hello.
What's your problem, man?
Mic is not. Your voice is not coming clearly, sir.
But no one complained me, na? Students, anyone respond, ma, please? Students?
It's clear only, sir.
My voice is clear, na, ma?
Yeah, sir.
Okay,
Sir, for me it's not clear, sir. So
what about other students, please, ma? Voice is clear, na? Sanjana? My voice is clear, ma?
Yes, sir.
Hello? Sanjana?
Yes, sir.
Voice is clear, ma?
Yes, sir.
Okay, ma. Thank you. Okay, ma, please. Sum of 25 terms of the series 1 into 3, 2 into 5, 3 into 7, plus and so on is. So here first we have to find 25th term. First identify nth term. Then instead of n, consider 25. Here first term is 1 into 3, second term 2 into 5, third term is 3 into 7, and so on. First we have to calculate nth term. Then instead of n, we have to write 25, then sum of 25 terms. Okay? Please listen. Clearly nth term, Tn is equal to, clearly Tn, nth term. It is n into 2n plus 1, n into 2n plus 1. If n equal to 1 consider, it is 1 into 3. If in case n equal to 2 consider, 2 into 5. 3 consider, okay, na? 3 into 7. So clearly nth term is n into 2n plus 1. So it is also 2n square plus n. It is the nth term. But here we needed sum of 25 terms. Now Sn is equal to Sn. Sn means sum of n terms. Sn is equal to sigma Tn. Sigma Tn means it is clearly sigma 2n square plus n. So 2 into sigma n square plus sigma n. Already you know that sigma n square, n into n plus 1, 2n plus 1 by 6. Okay, na? sigma n, that is n into n plus 1 divided by 2. So now this is Sn is equal to n into n plus 1 2n plus 1 by 3 plus n into n plus 1 by 2. It is a sum of how many terms? Sum of n terms. But we needed a sum of 25 terms. So instead of n, we have to substitute 25. Put n is equal to 25. Put n is equal to 25. If n is equal to 25, then it is S25 is equal to n value 25. It is a 25. 25 plus 1, that is a 26. 25 into 2, 50 plus 1, 51 divided by 3 plus 25 into 26 divided by 2. Then calculate. Okay. Now it is clearly 25 into 26 into 17, 25, 26, 17 plus 25 into 30. So here we get nearly 11,375, please. Okay. Please write down. Shashank, please mute your mics and audio and video both, please. Okay, ma? Next. Completed, ma? Question number 4. Please observe this one. 4 power 3 plus 5 power 3 plus 6 power 3 plus and so on plus 10 power 3. Given 4 to 10. Given 4 to 10. So this is 4 power 3 plus 5 power 3 plus 6 power 3 plus and so on 10 power 3. Here we added 1, 2, 3, 1 power 3, 2 power 3, 3 power 3, 4 power 3 and so on up to 10 power 3. Here 1 to 3 is additional value. So minus 1 to 3. 1 power 3, 2 power 3, 3 power 3. Remaining same term plus 1 to 3 minus 1 to 3. Then we get given data 4 to 10. In this 1 to 10, clearly it is sigma n power 3. But n value 1 to 10. The sum of 10 terms. Sigma n power 3 minus. It is 1 plus 8 plus 27. Now it is sigma n cube. Already we know that the sigma n cube formula n square n plus 1 whole square by 4. N square n plus 1 whole square by 4. But here n value up to 10. So sigma n power 3 is 10 square. 10 plus 1 whole square. That means 11 square divided by 4. Okay, na? N square, n plus 1 whole square divided by 4 minus 36. Then calculate. It is maybe 25 into 11 whole square is 121. It is 100 by 4 25. It is 121 minus 36. So it is 3025 minus 36. So clearly we get 2989. Please write down third option. Okay, ma? Next. Next question. Please observe this one, ma. Here, the greatest positive integer which divides n plus 1, n plus 2, n plus 3, n plus 4, and so on, n plus r. Total how many terms, ma? Total how many terms? R terms. It is the greatest positive integer which divides n plus 1, n plus 2, n plus 3, n plus 4, and so on up to n plus r. Please observe here, ma. It is first term 1, 2, 3, 4, 5. All are product. Clearly, product of r terms is divided by r factorial. R factorial means product of r terms. Here, how many terms? R terms. It is first term n plus 1, n plus 2 second term, n plus 3 third term, n plus 4 fourth term, n plus r rth term. But it is all are product. Na? So clearly product of r terms is divisible by r factorial. In case product of two terms, 1 into 2, is divided by 2 factorial. Product of 3 terms, 1 into 2 into 3, it is divisible by 3 factorial. Okay, na? So product of r terms is divisible by r factorial. General standard condition. Please note down the product of r conjugate integers. The product of or conjugative. Conjugative means alternative. Conjugative or connective integers is divisible by r factorial. General statement or example. For example, product of 1 into 2 into 3, it is divisible by 3 factorial. So 1, 2, 3 divided by 1, 2, 3. It is divisible. Same as it is product of n terms. 1, 2, 3, 4 and so on up to n terms is divisible by n factorial. it is 1, 2, 3, 4 and so on n divided by n factorial means product of n terms. 1 into 2 into 3 into 4 into and so on n. So clearly product of n conjugative or connective integers is divisible by n factorial. Here given in terms of r. So product of r connective integers is divisible by r factorial. Please note down. Okay, ma? Next. Please observe this one. The sum of cubes of three successive natural numbers is divisible by the sum of cubes. That means 1 power 3 plus 2 power 3 plus 3 power 3. Okay, na? So the sum of cubes of three successive, not only 1, 2, 3. In case of 10 power 3, 11 power 3, 12 power 3, or 100 power 3 plus 101 whole power 3 plus 102 whole power 3, like that. Sum of cubes of three successive, not first three successive. Okay, na? Any three. Okay, na? Which is divisible by which number? It is divisible by 6 or 9 or 27 or 8. First, we consider any three terms or numbers. Let the three numbers, let the numbers be n, n plus 1, n plus 2. Okay, but according to data, sum of cubes of 3. So now it is sum of by data n power 3 plus n plus 1 whole power 3 plus n plus 2 whole power 3. Okay, na? If n is equal to 1, consider. Put n is equal to 1, consider. What is the result? 1 plus 1 power 3. If n is 1 means 2 power 3. Okay, na? 2 power 3 plus. If n equal to 1 means it is 3 power 3. So clearly it is 1 plus 8 plus 27. So clearly here we get 36. Then in case put n is equal to 2, consider. This 27 is divisible by 6 and 9 both. So n is equal to 2, consider. In case at n equal to 1, any one option is satisfied, it is correct. But here it is divisible by 6 and 9 both. So n is equal to 2, consider. If n is equal to 2, it is 2 power 3 plus 3 power 3 plus 4 power 3. So clearly it is value 8, 64. So what is the total value? 99. Clearly the both are divisible by 9. Clearly both divisible by 9. But in first at n equal to 1, consider first and second both satisfied. If n equal to 2, consider. Okay, na? If n equal to 2, consider, we get result is 99. That these two results divisible by 9 only. Divisible by 9 only. So clearly it is second option. Please note down. Okay, ma, please write the next question. Please observe this one, ma. The product of four conjugative natural numbers is divisible by. Product of four conjugative natural numbers. Product of four means it is divisible by clearly 4 factorial, na? Same model, same as it is like fifth question. Okay, na? So here the product of r conjugative natural numbers is divisible by 4 factorial. Here how many terms? 4. The product of 4 conjugative natural numbers is divisible by 4 factorial. 4 factorial means clearly it is 24. Please write down the product of r conjugative natural numbers is divisible by r factorial. It is general statement where r value 4. Therefore, here clearly it is 4 factorial. 4 factorial means 1, 2, 3, 4. So it is divisible by 24. Okay, next. Please observe this one. N power 3 plus 2n is divisible by n power 3 plus 2n.